Okay, so now this is the application activity one, two, three. So this is about uh, matrix multiplication. Uh, now, okay, so here we have one, two activities. So first, determine uh, whether matrices A and B in this sequence are conformable for matrix multiplication or not. It means that we have to find the product A times B in case multiplication is conformable with respect to these two matrices A and B. Okay, so now here we are going to answer. So this is about answer to application activity. Activity 1, 2, 3. Okay, so first matrix is A is equal 3, 1, 12, and then B is equal to 1. Second one, subquestion B, A is equal a row matrix 5, 2 with component first 5, second 2. B is a 2 by 2 matrix with the first column 3, 7, second column 2, 6. Okay, that is question number 1. Okay, question number 2. A company's input requirement over the next 2 months for two inputs X and Y are given in numbers of units of each input by the matrix M, first column, a 2 by 2 matrix, first column 2, 6, second column 1, 8. The company can buy these inputs from two suppliers whose prices for the two inputs are given by the matrix N, which is a 2 by 2 matrix. First column is 4, 5, second column 2, 1, where the two rows represent the suppliers and the columns represent the prices. So now, obtain the matrix for the total input. Obtain the matrix for the total input B, input B, for the next 2 months for both suppliers. Okay, so now in this case, let us start by number one. Okay, so now A, we have matrix A is the 3, 1, 12. Matrix B is 4, 2, 1. Okay. So now suppose you want to find the product. So this should be 3, 1, 12, and the second is 4, 2, 1. Okay. So now the first matrix A is 1 by 3 matrix. Second one is also 1 by 3. So now, according to matrix multiplication, as the number of column is 3 for the first matrix, the number of rows for the second matrix is 1. So they are different. 3 is different from 1, which means that the two matrices are not conformable. So we can't find the product. It is impossible it is so the product is not possible A and B in this order, in this sequence. For example, in this sequence are not conformable matrices. So in this case, we can't find just the product. Now, number B, subquestion B. So suppose we have a matrix. First matrix is a row matrix. Second matrix is the 3, 7, 2, 6. Okay. So now suppose that we want to find the product A times B in this order. So we have first matrix 5, 2, second matrix 3, 2, 7, 6. Now here the first matrix is 1 by 2 matrix. Second matrix is a 2 by 2 matrix. This is a square matrix. So which means that we can find the product, and in this case the matrix that we're going to have, it will be a 1 by 2 matrix, because the number of column of the first one is 2, and number of row of the second one is also 2. So in this case the two matrices are conformable, and we can find it is possible to find a 1 by 2 matrix. So here we're gonna have a 1 by 2 matrix. So in this case, so it is just 1 by 2 matrix. It means that it is a row matrix. First component here and the second component. Suppose you want to find these two components. The first one, take first row, first column, 5 times 3 plus now 2 times 7, 2 times 7. So that is the first component. Second component in the row, it is this row times the second column. We're gonna have 5 times 2 plus now 5, 2 times 6, 2 times 6. We have the second element, second entry. So now here we have 15 plus so it's just 15 plus 14. So second component we have 10 plus 10 plus 12. So now, which means that in this case this element is going to be 29, and 15 plus 14 is 29, and 10 plus 12 is 22 of the second element. So which means that finally the answer is 29, 22. In this case, this is the product of A and B. Okay, now let us think about now how we can answer now the second question. Let us find space here for answer question 2. Question 2. Okay, so this is it. This is sub question 2. In this case. Okay, now So we have a company's input requirement over the next 2 months for two inputs, X and Y, are given in numbers of units for each input by the matrix M. So start by this matrix M with a 2 by 2 matrix. So 1, 2, 1, 8. Okay. 260, 1, 8. Okay. Now the company can buy this input from two suppliers, those whose prices for the two inputs are given by the matrix N. We have matrix N also with components 4, 5, and 2, 1. Okay. So now in this case, the question is obtain. So additional information. The two rows represent the suppliers, and the columns represent the price. So we have suppliers for the rows. Column represent price. So we have prices, price, price one, price two, for example. So of price for the input, for example. So it could be for X, for input X and Y, for example, in this case. And columns represent prices, the row represents supplier. So we may have a supplier, first supplier, and second supplier. So the first supplier has this price, second supplier has these prices. So now now we want to obtain the bid for the next 2 months for both suppliers, for the first supplier and the second supplier. So this will be the product M times N, and because first one 2 by 2, second one is 2 by 2, so product is possible, and we're gonna have let us use brackets which are not curly brackets. Usually curly brackets are used for sets. So in this case we're going to have a matrix like this, and so the first one, okay, suppose first one is M, second one is N. So 2, 6, 1, 8, 4, 5, 2, 1. So let us look at how it will look like. So now the product, so these two matrices are conformable because number of column of the first is equal to number of rows of the second matrix. So the product here will be also a 2 by 2 matrix. So this is it. Because the first one is 2 by 2, the second one is 2 by 2. So as the number of column of the first is equal to number of rows of the second, so the product will be a 2 by 2 matrix here, as you can see, 2 by 2 matrix. Now, in this case, how to find this element? So this element will be first row times the first column, gonna be 2 times 4 plus 1 times 5. Now the first component in the second row, on the first the second component of the first row will be first row times second column, 2 times 2, 1 plus 1 times 1. Okay, in this case, now this element first element of the second row. So will be second row times the first column, 6 times 4 plus 3. Now 8 times 5, 8 times 5. Okay, this is it. This is this element. Now, if I want now the last coefficient, last entry, so second row times first second column, so gonna be 6 times 2 plus now 8 times 1. Okay, so now uh, results. So this will be 8, 8 plus 5. This will be 4 plus 1. This will be 24 plus 40. This will be 12 plus 8. Okay, so this means that we want the product m times z. So m times n is gonna be equal to now 8 plus 5 is 13, and now 4 plus 1 is gonna be 5, and 24 plus 40 is 64, and then 12 plus 8 is gonna be 20. So this is the bill for the next 2 months for both suppliers. So for the first supplier, so we have for the first supplier, so here we have 13.5, and the second supplier we have 64.20 in this case. Okay, now other information can be added, and with the further reading or further complement of this problem as it is structured. Okay, now we have come to the end of this video. So next time we're going to be talking about inverse of matrices, as we have enough information about some operations, especially binary operations, such as addition, subtraction, multiplication by a scalar, and now here multiplication of a matrix by another matrix, which is called just matrix multiplication. So this brings us to the end of this video, and next time we're gonna be talking about as I just told you that next time we're gonna be talking about so next time we're gonna be talking about the matrix inverse of matrix. Suppose if we have a square matrix which is invertible, we're gonna be looking at what are the conditions for matrix to be inverted. So inverse of matrix A. So what is it? So thank you very much for watching. So next time, as I told you, it is a promise. We are going to talk about inverse of matrix, which conditions are required in order to for a matrix to be invertible. So next time.